Hi everybody, it's Mrs. Silbering. One last video in Unit 6, and it's on direct variation. So please open up to page 19. Direct variation is when there is a constant rate of change but more specifically, this is the important piece, the starting point is always 0. The starting point is 0. So in real life, there are a lot of things that have to do with direct variation. I'll give a quick example. When you go to the dollar store, everything's $1. So a formula for the dollar store would be y equals 1x. Pretend it's the dollar store, everything's actually $1, not the candy and stuff. But y equals 1x. Say you have a sandwich sale and all the sandwiches are $5. Y equals 5x. I don't know. You're selling pretzels at the football game, and all the pretzels are $2 each. Y equals 2x. In general, it's y equals kx. And I know we use k, and this is going to be funny, but k is the constant of proportionality. Boy, that's a long word to spell. You're not going to have to spell that more than once. It is the constant of proportionality. That is a very long word for the dollar at the dollar store, $5 per sandwich, or like $2 per pretzel. Let's do some examples. So if you have a multiple choice, which equation correctly relates x and y when y equals 39 and x equals 3? So let's do it this way. If we plug 3 in, what do we get for y? 12 times 3 is 36. No, we need 39. That's wrong. 1/3 times 3, that's not right. Okay, how about this one? 13 times 3 is 39. We found our answer. Okay, I'm going to do the same thing for number 2. Plug 16 in. I'm going to start over here. 4 times 16, well, that's not 4. 12 times 16, that's not 4 either. 1/4 times 16, that's 4, and that's my answer. Number 3, 4, 5, and 6 are all the same problem. I'll do, say, 2 of them, and you'll do the rest. X and y are directly related with constant rate of change. Y equals 25 when x equals 5. Write a direct variation equation that relates x and y. So here's how you do this. You always start with the formula y equals kx. Now what I'm going to do is plug in my pieces. So 25 equals k times, 25 equals k times 5. Go ahead and solve for k, and you get k equals 5. That's the whole thing, guys. Part A, y equals 5x. For part B, you just have to read the question. Find x when y equals 85. 85 equals 5 times x. Go ahead and solve it. Let's do the same thing for number 4. I didn't mean to do that. Y equals kx. 36 equals k times 3. Solve for k. and you get k equals 12. So think about this like a $12 item. Find x when y equals 108. So 108 equals 12 times x. All you have to do is solve for 12. Solve for 12. It's been a long day. Solve for x, and you get x equals 9. Okay, if you need to stop here, just pause it. Okay, I'll do number 5. Y equals kx again. 13 equals k times 52. Divide both sides by 52. If you can, you should reduce it. So 13 over 52 reduces to, I'm double checking on a calculator, reduces to 1/4. I was not confident there for a second. The simpler the fraction, the better. So y equals 1/4 x. 1/4 for part B. Find y when x is 84. Just plug in that missing value. And our answer is 21. Go ahead and try number 6 on your own. I'm going to pause the video here. So maybe I should have done this one with you guys, but that's okay. You can check it now. This one had a funny number. The answer for k was 7 over 91. This cannot be reduced, and it's definitely not like a real world type fraction. But you see in part B, that didn't deter me. And when I plugged in 117, I actually got an answer of 9. Okay, if you have any more questions, go see your teacher.